name is Jason Worrelman. I lead our industry healthcare practice at UiPath, and welcome to our UiPath virtual office. So we want to bring you something special. Every week we've been bringing you a webinar series featuring some of our guest panelists, which are some of our partners and some of our clients, and how they're using hyperautomation today. At HIMSS 20, where we all hope to see you, we also had a number of demonstrations that we had custom created with our partners, our customers, and even internally in our innovation labs, showing some of our best feature technologies, including forms, attended automation, and how you can use that with email, all the way to artificial intelligence and how you incorporate that with AI Fabric. So what we've done today is ask three of our specialists, Melvin Hutchins, Javed Ali, and Lisa Weber, to come to us and showcase some of these demonstrations for you. I hope you enjoy these segments that we put together for you, and we hope to see you every week inside our webinar series. Thank you.
Hello, welcome to UiPath and Healthcare. I'm Melvin Hutchins, the Global Director for Healthcare Tech Alliances. And today we're going to be talking about solving interoperability and how to use that to improve the care coordination. We actually had a live webinar on this earlier this week. So I'd highly recommend you go check that one out as well. That was done in conjunction with Avanade, and really good back and forth, really good insights from Avanade on both care coordination, solving interoperability, as well as physician fatigue. So please go check that out, and thanks for joining us on this one. So what you're going to learn today is what you'll see are robots working by themselves, triggered by APIs. So we'll cover that in the first use case. Second, we're going to go into robots working from an OCR process. So essentially extracting data received from a fax and then having that trigger additional process downstream. You'll also see robots working with humans, with a human in the loop. So showing how we can essentially compress the work time associated with the provider. And lastly, also working with the provider with an attended automation, but a different scenario, essentially showing how robots can work to do data duplication, in this case, in separate systems, in this case for regulatory compliance. So it's nowhere do we even have access to that system. So excellent, thanks again for joining, and let's get started. So in the first use case, we're actually going to be working with Salesforce Health Cloud. So it's going to be focused around patient referrals and the coordination of patient referrals between Health Cloud and separate systems. In this case, we're actually going to have the referral entered into Health Cloud, and then the API will trigger and send it over. So let's get started. Oh, and what we saw was an 80% cycle time reduction, 80% reduction in human error. And then essentially the patient receives care sooner than they would have otherwise. What you'll see is an RPA developer, and we felt it was important to show this piece because you really can't show APIs. The RPA developer is going in and essentially setting up the trigger. And the trigger is what is essentially a robot that's listening out for the API call from Salesforce. We have built an integration to Salesforce, and you can download that via our marketplace. Anyway, that robot is set up within our orchestrator. The orchestrator is essentially the brains of the operation. It's the air traffic control. It's what controls robots and how they work. So once the API is received, that'll create a queue, or a work queue inside the orchestrator, and that queue is essentially where the work is assigned to a robot. So inside that queue, so the API is received, that triggers the work queue associated with the type of API call that it is. Orchestrator sets it off and sends that to the robot to start working. So the robot logs into, in this case, OpenEMR. And from that standpoint, the robot will look for the patient if it doesn't, based on the patient search criteria that the health system has set up. If it does not find that patient, it will create a new one. And then what we're doing, what you see here right now, is that the robot is going through and entering all the patient demographic information that it receives via the API, via Healthcloud. And next, it's going to add in some of the additional data, such as history information associated with that patient, family history, all the additional information that you're going to receive within that patient demographic information. Once that information is entered and they've completed the patient registration, if you will, what you'll see is the robot looking through the calendar, finding either the requested date or the first available, and it selects that first available appointment, saves the appointment, and sends that back to Healthcloud so that the patient knows the time and location and the physician that they'll be seeing. So all of that is done within the API. So in this case, what we've seen is, and this is just a reference back to the transaction. So you can see that the transaction actually happened. The robot did process all that data, created the appointment, and sent the notification back. And that is our first automation that we're going to be covering. In our next use case, we're going to be talking much like the first, where there was an event that happened in an external system. In this case, it's actually going to be a fax coming in, as opposed to our first use case, which we had an API trigger from Salesforce Healthcloud. So the system will receive the fax, or the practice will receive the fax, and then that's when automation starts, when that event happens. What we'll see is essentially automation creating seamless data integration across multiple platforms, real-time communication, really a 35% reduction in data entry errors, as well as a reduction in the entire process as a whole. So let's go ahead and jump to that video. So this video will show the lifespan. We'll actually take a quick break to show you Studio as well. That's where design happens within our platform, so you can better understand how we create automation, but just briefly. So this setting is actually put into Gordon Casson. He's actually seeing his PCP, primary care physician, and that physician is going to create a universal healthy child record, and he's going to be faxing that health record to the care provider. Essentially, that fax is going to go in and be consumed by a robot. Then what you'll see is a validation station happen, and then that transmitted via FHIR, Microsoft Azure. So what you see now is our Studio. This is how automation is designed. We have about 300 activities, more than that today. But essentially, it's very drag and drop, very user-friendly. So you can create automation, and we can see here now with Gordon, he had a total of 89 observations. So the robot will actually, in this case, we're going to go ahead and run this automation. So we will receive the fax, and that robot essentially will process the fax and extract the data that will be associated, that they'll have to enter. And as you can see now, the universal child health record, it's consuming that. It's going to represent that to a specialist in what we call a validation station. So it allows a human to ensure that all of the items are correct without having to manually enter them, and then they okay that. And it also has a machine learning algorithm associated with it that improves over time. The robot's going to log into the EHR, and in this case, just going to ensure that that we have the correct patient within the system. So it's going to look up Gordon and validate that he is the right patient. And then in the background, what's going to happen is that the robot is going to send via FHIR to the EMR all of the data associated with that visit, and successfully update it. We'll go ahead and refresh the screen here on that and show that indeed in this live demo that the observations were updated for Gordon. What it did in conjunction with that, and really in the next step, what we're really trying to do is close the gap. So provider to provider, updating the observations in the system, and then actually in the next step, what we want to see As you can see, the growth chart was updated in Azure in the cloud. So it is accessible by all of the care providers associated with Gordon. But we also did push this to MyCare AI, which is an app on a phone. It's a patient interaction tool. So Gordon would have the ability to not only communicate with this provider, but keep track of all of the visits and observations that his provider had made. So they have the ability to push this out directly into his mobile app via FHIR once we push it into Azure. So it's communicating and collaborating with patient, physician, and actually the patient in the end. So pretty awesome use case, and glad we get to share it with you guys. So our next use case, which I'm super excited about, is an actual use case that comes from the California corrections. And what we found there was essentially one of the challenges they had is essentially 11,000 inmates transfer in any given month between facilities. And at their facilities, while there's Cerner across the entire ecosystem, essentially the challenge that they have is, you know, they are independent organizations within themselves. So each individual health system operates as its own individual, or each individual facility operates almost as its own health system, if that makes sense. So this is going to bring a provider into the loop. What we're going to see is a 95% reduction time, 100% accuracy rate entering in that data. And in this case, we're actually going to save the providers 2 to 3 hours per day. So pretty exciting. So here you can see what we're looking at here right now is actually Cerner application. We kicked off the automation. It requested that the provider put in the member data. What it's going to do now is that once the robot is working right now and bringing up the provider or the individual person, and the physician had created and selected the encounter, and the robot asked, hey, do you want to move these orders over from that new encounter? So the action you see now without the mouse on working is all the robot. Now we're back to the human in the loop. So the provider has an opportunity to see which orders within the system they would like to transfer to the new encounter. And that was really the problem, is that previously when they would see that patient move within the system, essentially the breakdown was, or the interoperability within the own system was that it was seen as outside data. So the provider would have to select those orders and create new orders for that patient in the existing system or in the existing encounter. So it's treated almost as outside data. So the provider did select the orders. They went through, the robot created those orders, or actually copied all the data associated with those orders. Now, there was a pause there, and it asked the provider, do you want to move forward with moving this? And they said yes. And now the robot is actually creating the orders for all the medications, laboratories, as well as the new consults, and moving that through the process of creating all of those new instances or new orders in the new instance. Sorry. And, you know, you might ask me why we are doing a human in the loop in this case. And the real reason is that ultimately the provider still has the control over the process, the selection of the patient and the orders that they want to manage. So they're still making the decisions on patient management and what they want to do with that new patient for them. But we're removing all of the data entry, we're compressing all of the activity within the EHR. So essentially, the provider is really only making decisions at the decision point, and all of the other data entry points are completely removed from their process. Really great observation. So if we could save a physician 2 hours a day, who happens to be the most costly asset inside of a health facility, that's a big win, not only for the providers themselves, but for the facilities and the patients, because essentially they can see more patients, they have more time to process information. And in today's world, with right now, if you're watching this in a future state, we're about one month in to healthy at home or distancing for COVID-19. So being able to do more for patients outside the epidemic is going to be key. Once all of the data has been entered into the system by the robot, the physician is going to be presented with a stopping point that says, hey, still remember that now that all of the information is entered, you still need to sign the data. And that's why we have signed the orders. And that's why we've done it as a human in the loop, because the physician is logging in with their credentials. They are creating, the robot is creating and moving all the information, all the data, but they are still at the point, and this is still the record of the source record. So physicians are still in control and just eliminating any key or typing. So love that use case. I think it's fantastic. What I would say is that it may be unique to California Corrections Institutes, but in the 2 years that I've been here at UiPath, I've seen a million unique issues, whether that be in radiology or any other discipline. So absolutely think of ways how UiPath can help you improve your productivity and create more efficiency for your providers. And our last use case, which I think is also just fantastic, but it really is a 10 out of 10 win for the providers. And so what we had was there's a charitable organization up in New York, and for lack of a better term, essentially what they had to do. Well, let me cover this first. There was from the benefits perspective, what we had was an 80% cycle time reduction, 75% increase in accuracy, and a 65% improvement of real-time access to clinical data, which is key. And it's all around kids. I mean, it's really around kids in need that need to go into clinics for these specific, more needy kids. But just a super, super fantastic use of the information. And I'll move over to the video so we can talk through what's happening. So as you can see, there's our studio there. Again, get ready to start up and go, and we'll start and run the automation. So what the use case was essentially is that the providers who were seeing these underserved children essentially had to not only document the case or the encounter in their EHR, but they also had to document it in a system called Connections for the state of New York. And I can completely appreciate that, absolutely. But the challenge is that those systems aren't connected. The state system, which is really for monitoring, has less to do with the clinical care of the patient, but even though, they are combined but not connected. The state uses it for a different purpose than the physician does. Needless to say, still needs to happen. Still needs to be updated. So what you see the robot doing now, it's actually logged into Connections. It is searching for that patient within the system. Excuse me. And once they have found the patient, it'll actually go through the process of creating the progress note and entering all that information into the data. You'll see all the patient information is redacted here. But what you can see is the robot essentially navigating through that process, finding the patient, selecting the patient. It is going to ultimately encounter challenges in the process where you have essentially drop-down menus, or it doesn't see that patient on the screen, so the robot knows to scroll down to look for more information. But excuse me, all of that information is going to be, all of the data that's being entered was essentially copied from the original EHR, and now is being entered by the robot into the state system. And how that works essentially, and we used to call this really a gaps in care project, was essentially when in a real life scenario, when the physician clicks save on the progress note, that's when the robot moves into action. The robot essentially copies all the data within that progress note, goes to Connections in the state, opens up Connections, and starts entering all the data. Prior to this, the physician physically would have to enter the data in twice. They would have to do the progress note in the EHR and also do the progress note in connection. So once the robot has completed their process in connections, they're going to log back into Evolve, which is the EHR that the providers are using, and annotate the fact that yes, all of the data is in connections and has been entered, so they'll have a record of it. And we see this in many other types of formats where, much like in the case of opiate abuse, I need to validate that I have entered the data for the state, and I'll get a record or a record number, and that record number has to be entered into the EHR. But that's it for our automations today. I truly appreciate you joining us. Please come back and see more, and we will talk soon. Have a good day.